Ok, finalize. Ok, thông tin nó update mà cái này chưa reload lại, chắc cái này là đang bị lỗi. Đây, cái thông tin nó sẽ khi mà claim thì nó sẽ trực tiếp vào cái balance của user luôn, token luôn. Cái này hình như có in à? Cái này là hỗ trợ cho, không, cái này thì không phải. Cái này mình thấy. Ok, mình đã tóm tắt lại ba cái phần ờ, session của cái phần session cuối này. Và trong cái phần workshop này thì mình sẽ gọi là bắt đầu mình sẽ ờ, gọi là chính thức tham dự liên quan tới hackathon, và mọi người đăng ký trên cái form nhé, để đăng ký team, rồi đăng ký cái ideas, rồi sẽ tạo nhóm, rồi sau đó thì mình sẽ mình với thêm một số bạn nữa sẽ có hỗ trợ cho mọi người hết sức có thể ha. Mọi người có câu hỏi gì không? Mọi người có câu hỏi gì không? Nếu mọi người không có câu hỏi gì thì mình bấm số 1 nhé. Ok. Hoặc là có một ý tưởng làm kiểu stacking multi chain. Stacking multi chain. Rồi sau đó sử dụng liên quan tới công nghệ SCM á. Thay vì mình deploy rất là nhiều chain đúng không? Thì mình chỉ deploy một chain thôi. Rồi sau đó mình sử dụng liên quan tới SCM tương tác với in smart contract. Cái đó thì cũng khá là hơi advanced ấy. Tương tác với smart contract, in smart contract, rồi mình sẽ chuyển cái mình có thể kiếm cái gọi là cái, có thể là kiếm cái tokens reward từ những cái multi chain khác chẳng hạn. Ok nha mọi người. Không biết mọi người có chạy thử cái này không? Cũng dễ, cũng không phải là khó đâu. Nói chung là cũng không phải là chưa chưa phải là đến mức ok, bởi vì mình chỉ việc để làm sao để show cho mọi người cái gọi là cái cơ bản nhất và cái ứng dụng của nó. Mọi người phải phát triển thêm ấy. Ok, vậy mọi người bấm số 1 rồi thì chắc là mình phải chờ qua cái workshop khác. Ok, chắc là mình sẽ qua cái workshop khác ha. Rồi, mình xin phép stop ha.
Alo, alo, mọi người nghe không? Nghe không? Alo, nghe mọi người ơi. Hôm nay workshop mình là tiếng Việt nha. Ờ, vì vì lý do trái múi giờ cho nên là guest speaker không join được, tại vì hiện tại ở khu vực của guest speaker là đang 5 giờ sáng. Thì cho nên là hôm nay là mình sẽ lead cái workshop này luôn. Nhưng mà đổi lại cũng sẽ có một cái video từ từ guest speaker là anh Devrail của Moonbeam, thì mình sẽ show cho mọi người coi, xong rồi sau đó thì sẽ hỗ trợ mọi người để mà host cái workshop và cũng như trả lời những cái như là về Q&A. Thì chắc là mình đợi thêm tầm 3 phút nữa để mọi người vào đông đủ rồi xong mình sẽ bật video cho mọi người coi nha. Mọi người thấy screen hông? Khi có gì xui thì share giúp em nha. Cái này mở tiếng rồi đó nhưng mà nó hông
Hello, everyone.
Hello,
It's Kevin,
everyone. It's Kevin,
and thank you so much
and thank you
for
so much
joining
for
me for
joining me
Moonbeam's
for
workshop
Moonbeam's
for the
workshop
Polkadot
for the
Vietnam
Polkadot Vietnam
Hackathon
Hackathon
2024.
2024.
As you may know,
As you may
Moonbeam
know,
is
Moonbeam is
participating in
participating
the
in the
RWA, or
RWA,
Real World
or Real
Assets
World
track,
Assets track,
and we're
and
sponsoring
we're
three
sponsoring
different
three
bounties,
different
or
bounties,
one
or
bounty,
one
but
bounty,
three
but
different
three
prizes.
different prizes.
There's a first place
There's a
prize
first place prize
of
of
$1,250, a
$1,250,
second place
a
prize
second place
of
prize of
$750, and a
$750,
third place
and a
prize
third place
of
prize of
$500.
$500.
And each
And
of these
each
three
of these
prizes
three prizes correspond
to the challenge
to the
of
challenge
building
of building
real world
real
asset
world asset
solutions on
solutions
the
on
Moonbeam
the
network.
Moonbeam network.
So in order to
So
get
in order
started,
to
I
get
figured
started, I figured it would be best to start with an introduction to the Moonbeam network
and kind of
and
take you
kind of
through
take you through
what the Moonbeam
what
network
the Moonbeam
is and
network
how you can
is
get
and how you
started
can get
building
started building
on
applications
top of
on
it.
top of it.
So we won't
So
dive
we won't dive really
into
into real world assets deeply. Instead, we'll be looking at how you can launch smart contracts and applications on top of Moonbeam. And it's really up to you to decide how you build and design your RWA solutions. With the idea and keeping in mind that this is a hackathon. So we're not expecting you to have perfect solutions. We're not expecting you to have finished and complete applications, but just jump out there and try to build something that's fun and interesting and exciting. And so some of the existing solutions that Moonbeam has out there, or that teams are working on, include Carbify, which is a carbon credit marketplace. And another example is Transfero, which is a stable coin that is pegged to the Brazilian real.
And
And this is launched on Moonbeam. There's also one called Tokeniza, which is decentralizing investment in terms of real estate, debt instruments, and startups. So these are just a couple of examples to get you thinking, and these are ones that are already out there. So just to get you thinking about real world assets, and we can't wait to see what you build. So with that, let's go ahead
and jump into the rest of the workshop.
So first, let's start off with what is Moonbeam. Moonbeam is an Ethereum-compatible smart contract platform on top of Polkadot. Moonbeam is a layer 1, and it's built on top of the Polkadot layer 0. So what we mean by that is that you can deploy to Moonbeam just as you can to any other EVM-compatible network, such as Ethereum, such as Binance Smart Chain, such as a layer 2 like Arbitrum. The deployment process to Moonbeam is exactly the same. And so I want to talk a little bit about how Moonbeam is designed and architected, so that you can better understand how we work. So as I mentioned, Moonbeam is a layer 1 blockchain that's built on top of Polkadot. And Polkadot is built with the substrate architecture. So that means that parachains or layer 1s that are built on top of Polkadot are also built with this substrate architecture. So Moonbeam is built with Substrate. Now you don't need to learn Substrate itself
in order to develop apps and deploy on top of Moonbeam. The substrate components are mostly for the engineers of Moonbeam itself who are building.
And there are things that you can do with the substrate capabilities of Moonbeam, which we'll certainly talk about, but you don't need to actually have a knowledge of how Substrate works, because a lot of the cool features that Substrate enables, we actually make available to you through a Solidity interface, and that's where our precompiles come into play. But the important thing that Moonbeam has to offer, in addition to our EVM compatibility, there are a number of things. But one of the really cool features that we have is we have deterministic finality, and that's thanks to the Polkadot relay chain. And we actually now have 6-second block times. It used to be about 12 seconds. It was chopped in half. And with this deterministic finality, that means you can have a definitive yes or no answer to is a block finalized or is a transaction finalized. And we also have an API that you can query. You can pass it the hash of a transaction or the hash of a block, and you can receive back an answer of yes or no, is this block finalized or not? And that typically happens within about 12 seconds. So if you're querying a block that's older than that, usually that's going to be finalized. But you can always get a yes or a no answer by querying the Moonbeam API. And this is important for if you're building particularly a financial smart contract application, such as a DeFi application, perhaps a game, perhaps you want to take some action or move a user along, or allow a user to continue, for example, within your interface, perhaps only after a finality has been reached. And so you can have your UI be checking, and once this finality condition has been met, you can move along. So that's a very important component of Moonbeam. And I also wanted to mention that Moonbeam is fully Ethereum compatible. And this means that you don't have to change any of your methods such as ETH get balance or estimate gas or anything like that. All of those methods that you're used to working with, those are exactly the same. You don't need to change the units or anything like that. So we have a fully Ethereum compatible Web3 RPC, which accepts the same requests that you would send to an Ethereum node. We also have a unified account system. This is very important because Polkadot actually uses a different style of account. So it has a different private key and a different public key than Ethereum does. So the actual length of the account address is different. And so if you wanted to have a system where you can interact with both Polkadot and Moonbeam, meaning both Polkadot, the substrate style of Polkadot, and you want to interact with an EVM, such as Moonbeam, typically you would need to have two different styles of accounts. You need to have your Polkadot account to interact with the Polkadot side. You need to have your Ethereum account in order to interact with the Moonbeam side. But this is not a very sustainable architecture. It's complicated. You have to ask your users to maintain two different types of accounts. So we said absolutely we are not going to have these two different types of accounts. Rather, we're going to develop a unified account architecture. And that's what Moonbeam has had since the very early days, is a single Ethereum account that allows you to interact with both the Polkadot side and the Moonbeam side. So you take your existing available on Moonbeam all through your existing account. You don't need to go and maintain two different types of accounts. So that was a big lift early on, but it set the stage for the compatibility and user friendliness that users have come to know and love about Moonbeam. So that was very important to have this unified system of accounts. I think I've touched a little bit on the fact that Moonbeam is Ethereum compatible, but we also integrate some of the best features that Polkadot has to offer through Substrate. And what this means, simply stated, is that you can query a Moonbeam node through both the Ethereum API or the Substrate API. So whichever you're more comfortable with, depending on the design of your application. And as I kind of said, if you query a Moonbeam node, if you send it the same type of request that you send to an Ethereum node, you'll get back exactly what you are expecting. And so what this means is that you don't need to re-architect your application from the ground up. If you've already built, a website and a dApp for Ethereum, you don't need to go and do all of this complicated, switch over in order to make it compatible with Moonbeam. You can actually add the Moonbeam network very, very easily. So as an example here, if we're making a call to an Ethereum node, we will get back a response, that's exactly what we're looking for. So in this example here, right, we can submit a call. It could be either, a read call. It could be a transaction that we're submitting in order to change state. And we'll get back a response, letting us know the status of that transaction. So one type of RPC request that we could make is we could say ETH get balance. And we're going to provide an address here as a parameter. That's the only parameter here that we need to provide. And we will get back an answer that says something. It'll be in hexadecimal, but we can convert that and we can get back the response that we have 4.85 Sepolia ETH tokens in this case. But we can make that same request to a Moonbeam node on either Moonbeam, Moonbase Alpha, and we can get back that same balance. but rather it will come back with dev tokens or Glimmer tokens for Moonbeam. So Moonbeam's Ethereum compatibility is enabled by a module called Frontier. And Frontier is an EVM compatibility layer that has originated, from Polkadot and Moonbeam developers. So what Frontier does is Frontier translates and essentially replicates all of the functionality of an EVM in a substrate architecture. So this is really important. What it allows you to have is a fully seamless and fully compatible EVM developer environment that's running on this substrate architecture, which is really fundamentally it's very different, from the way that Ethereum is constructed. But the end user experience and the dApp developer experience, is much the same. So you don't need to go out and learn all about Substrate and Polkadot. You can actually develop on Moonbeam without having to know all of that. And so Moonbeam has a runtime, and that runtime is how the state transitions are managed, just like with another Polkadot parachain. And Frontier is this compatibility layer, which allows you to send an EVM call into Moonbeam and have that be acted upon, in the correct way. So what does this all mean? That you can connect to the Moonbeam network and you can develop on the Moonbeam network just as you would with Ethereum or another EVM compatible network. So of course we've got RPC endpoints which you can connect to. We've got a full list on our documentation site. If you just Google Moonbeam RPC endpoints, the first link that comes up will show you all of the different options. And even faster than that, we've got, and I can show you, we've got a docs.moonbeam.network. If you head there and you click on Connect Wallet, this will prompt you to connect to either Moonbeam or Moonriver or Moonbase Alpha. And when you are connecting to any of these networks, just click on it, and then it will prompt you to connect. And it'll have everything pre-filled, the network URL, the chain ID, the currency symbol, and all you need to do is press approve, and it will add this to your wallet. So you don't need to go in and edit it manually. If you'd like to, of course, though, you can go over to endpoints here, and you'll see for each network, we've got a big list of RPC endpoints as well as WebSocket endpoints here. And we've got Moonbeam, Moonriver, and Moonbase Alpha. So now it's as good a time as any to talk about kind of the differences between the three networks. So Moonbeam is the mainnet network. Moonriver is a canary network. This is kind of a concept unique to Polkadot. A canary network is kind of between a testnet and a mainnet. It's not a testnet. It's meant to be a more experimental mainnet. And one of the big advantages here is that when you deploy an application to a testnet, there's no value on that testnet. And so what that means is that users are not really incentivized to really try out that contract. They're not going to try to exploit it or try to poke holes in the contract because it's just a testnet. And so Moonriver and canary nets in general are meant to provide an environment where it's as realistic as can be and as close to production as possible with real economic value behind it. So perhaps there are some assumptions that you made in your testnet deployment that really can be validated and fully tested in a canary network with that real economic value there. So that's what Moonriver is. And Moonriver also launched a little bit earlier than Moonbeam. So Moonriver launched back in August of 2021, and Moonbeam, the mainnet, launched in January of 2022. So Moonbase Alpha is, of course, the testnet, and so you can get tokens from faucet.moonbeam.network, and you can go ahead and get tokens here. So heading back to the presentation here, I mentioned getting tokens from the faucet. I also wanted to mention some of the different libraries that work with Moonbeam. And now a common theme, of course, is that you're noticing is that Moonbeam is extremely compatible. And it isn't compatible through means of a fork or through means of some big difference. Rather, Moonbeam is natively out of the box compatible with all of these developer tools and developer libraries. So Moonbeam itself is compatible with Ethers, with Web3, with Web3.pi, with Foundry, with Hardhat, with Metamask. So you're noticing that all these tools, right? They don't need to be specifically adapted or anything like that. They work straight out of the box with Moonbeam. For connecting to Moonbeam, we start by importing ethers, and then we create a Moonbase network, and we specify our RPC URL. We specify the chain ID for Moonbase Alpha, which is 1287, and we provide a name that we will reference. We can do a similar action for web3.js. And in order to configure web3.js for Moonbeam, or Moonbase Alpha in this case, all we need to do is import web3. And then we are going to define a RPC connection here. And this one is just the RPC URL for Moonbase Alpha. We can also perform a similar set of actions here for configuring Hardhat for Moonbeam. We can import these two packages, Hardhat Ethers and Hardhat Ignition Ethers. In this demo example here, we have a private key, but typically you would rather want to define this in an env file or in a secrets file, something to keep it safe so that you don't accidentally commit it to a repository and upload it for the world to see. Of course, another very good security measure, which I always perform, and I hope that you do as well, is that you keep your developer accounts separate from your mainnet accounts. So you use a totally separate private key here for any sort of testing that you do. So even if you do forget to define it in an env or in a secrets.json, if you do accidentally commit it, well, you have only committed, your development private key, and you hopefully don't have any real funds on that account. In our Hardhat file, we're going to specify the version of Solidity that we're going to work with. We're also going to define the networks that we're going to work with. So you might have, a slew of 5 different networks or 10 or whatever it is defined here. So in this case, we have Moonbase Alpha. We have our RPC URL here. We also have our chain ID, which is 1287. And then we have the accounts as well. So you might have Moonbase, Moonbase Alpha, there's the same, sorry. You might have Moonbase, Moonbeam, Moonriver, Ethereum, a couple different Ethereum testnets, that type of thing. And when you have this defined in Hardhat, then when you're deploying and testing, you can specify which network you'd like to deploy to. And then, of course, Hardhat will know, it'll reference your configuration file and see exactly what are the details of the network that you're asking about. Moonbeam also works with Forge, and Forge is a tool that's offered by Foundry. So Foundry is a very powerful, developer tooling, which has different, command line tools. It has tools for testing. It has tools for, as part of this testing, you can print out various bits of information about your contracts. And so Foundry is quite popular. And of course, Moonbeam works with Foundry. We have a docs page for Foundry. We also have a video, a long form video on our YouTube. So if you search for, or if you just go to Moonbeam Network's YouTube and you search for Foundry, you'll see we have quite a detailed video for getting started with Foundry and working with Moonbeam with Foundry. Okay, so another important piece to know about the Moonbeam network is that we didn't just take an EVM and call it a day. Polkadot has so much to offer. There are a ton of powerful features that Polkadot has to offer, which we benefit from by being a layer 1 that's built on top of Polkadot. So it really would be, a shame if we didn't offer you all these powerful features that Polkadot has. And we've worked really, really hard to provide you with easy access to these powerful Polkadot features. And when I say that, I mean there are so many different ways that we've done this, and so I'll jump right into that. So as I've sort of mentioned so far, right, you have access to both the Ethereum API through Moonbeam, and you have access to the Substrate API. Now, you can interact directly with these Substrate palettes through the Substrate API. So if you want to, get a particular balance, or if you want to submit a staking activity, if you want to query a palette for asking about the status of a governance proposal, you can do that directly through the Substrate API. But what if you want to access these type of features? What if you want to access it through the Ethereum API? And that's where we've done all of this work, is by building these precompiles. And these precompiles are Solidity interfaces that allow you to dynamically interact with these Substrate palettes. So this means you can not just read information, but you can also write information. So you can submit transactions through these precompiles that will then go and directly access Moonbeam's runtime and interact with these palettes. So this is important for a number of reasons. For one, you don't need to go and learn about how Substrate works, about how the palettes work, about how Polkadot's kind of architecture works. You can simply have a precompile, which is a Solidity interface, and you can interact with that interface without having to know what the underlying Substrate architecture looks like. So that really is the best of both worlds, is that you have this familiar Solidity interface, and with this Solidity interface, you can choose to interact with it in kind of a one-off fashion. So you might just make a call to the interface, perhaps through a website front end. You might have a dApp that prepares transactions to interact with the precompile. And that's actually how our staking dApp works, is that it prepares transactions that use the staking interface .sol, which is a Moonbeam precompile that interacts with Moonbeam's staking palette. So that's one option. The second option is you might have a smart contract, and most of the precompiles can actually be called by other smart contracts. So an example here is you could create a staking DAO or an on-chain staking application, which has logic in order to call the staking precompile. So perhaps when the contract reaches a certain threshold or other conditions are met, then the contract itself autonomously can go and call the precompile, for example, for staking or for other ones as well. So that's really cool. So the two ways through which I mentioned are kind of a one-off fashion that you trigger a transaction through an interface, through a website, and that will make a transaction and it'll call the precompile. And the second way is you have a smart contract which calls it once some logic is hit, or perhaps just a method that you interact with in the smart contract then goes and calls the precompile. So that's certainly an option as well. So with precompiles, right, you do not need to learn about Rust. You don't need to learn about Substrate. You can take your existing dApp developer knowledge and you can apply that in order to interact with the features that Moonbeam has to offer through its precompiles. you don't need to learn about the Polkadot.js SDK, which is a JavaScript and TypeScript SDK that allows you to interact with the Substrate API. You certainly can if you want to, but you don't have to. We're all about providing developers choice and options, and so we want to give you, the widest array of choices and options possible. So if you're comfortable and you prefer working directly with the Polkadot.js SDK, you certainly can. We're not going to stop you. But we want to provide you with the options such that you don't have to. Polkadot does have a lot of terminology and a lot of acronyms and a lot of Polkadot specific language. And so you don't need to learn all this in order to interact with the Moonbeam precompiles. Instead, there are just a couple things that you need to know, and it's actually really, really easy. You only need to know what functionality are you looking for. So for example, if I'm looking to stake, right, I need to know that I need the staking precompile. If I'm looking to combine transactions together, you're looking for the batch precompile. If you're looking for creating gasless transactions, then you would need to know about the call permit precompile, which is the precompile that offers gasless transaction functionality. It allows you to have your users sign a message, and then you can dispatch that transaction on their behalf, such that they don't need to have any native token or provide any native token to pay for gas fees. So you need to know what functionality are you looking for. The second piece of information you need to know is what is the address of the precompile. So precompiles behave as already deployed smart contracts. So they're already out there at a particular contract address. You don't redeploy them or anything like that. You just need to know where you can access them. So you need to have the interface and the address at which to access them. And all of this you can find in the Moonbeam docs. And we're very careful about making sure to always include in the comments in these interfaces, we always have the address of the precompile in the comments. So even if you're just in the GitHub and you're not actually on the docs site, you can still see the address for the precompile and where to call it. And of course, number 3, what function do you want to call? Some of these precompiles don't have that many functions. Maybe it's just 1 or 2 or 3, but some of them have many, and you need to know exactly what function you want to call and what parameters that you need to pass to it. But all of this is very logical, and it makes perfect sense. So such that if you're staking, right, the parameters that you need to provide to this method are going to be very in line with your expectations. So that would be like amount, that would be what is the Moonbeam collator that you want to stake with. That is, do you want your staking delegation to be auto-compounding? And all of that is information, that you would expect to provide. Okay, so precompiles, they provide a way for you to access Substrate functionality that wouldn't otherwise be available, to the Moonbeam EVM, and that's a huge deal. One of the reasons that we have all of these precompiles is also to enable better user experiences. And these user experiences can help to enable you to provide your users with wonderful, easy, elegant solutions. In some cases, one example is you may want to make it so that your users don't need to have a smart contract wallet, for example. And this is possible through smart contract wallets, not directly from these end user accounts. So in these cases, you might have a user create a wallet from an email address, or you might have one that's just embedded in a website. Maybe it's a short-term wallet that they don't need for long, and a website can keep it on their behalf or something like that. So there are many options there. And again, this is about providing a variety of options for you and for your users. We're not saying that you need to take this approach. We're just saying that this is one of the possible approaches that you may wish to take, and we want to provide you with that optionality. Yeah, we have a number of teams that have improved the user experience by using things like the batch precompile. And the batch precompile combines multiple transactions together in a way which is logical and smart. So what I mean by that is you can choose different groupings of the way that your transaction is grouped and whether it succeeds or not. So rather than just grouping up a bunch of transactions and saying, let's try them all and see what happens, we can choose to do that, or we can choose to say, hey, let's make the batch transaction succeed only if all of the individual transactions succeed. So if one fails, let's make the whole thing fail. That's one possible approach. A second possible approach is you might want to batch all the transactions together until one fails, in which case you just want to stop right there. And don't try to execute the later ones, even if the later transactions would be successful. So that's called batch sum until failure. And yeah, that is one approach. And another approach is just try to execute everything. It's okay if some fail, not a problem. Just keep going. Keep trying to execute all the transactions that you can. And that would be batch sum. And so, yeah, we have this diagram here where we have multiple calls. Yeah, you can have more than two. You can have a very large number of calls. Of course, this is going to be dependent upon the block's gas limit. There is a theoretical limit for the number of calls, but it's in the hundreds. And so you're more likely to run out of gas space, really, than to run into this actual limit. But one of the cool optimizations, of the batch precompile is that you can save your users gas, and you can also provide a better user experience. What we mean by this is if you have transaction A and transaction B, and they execute them separately, right? The gas that you're going to use for transaction A and transaction B, you can combine that together, and whatever you use in the batch precompile is going to be less than the sum of executing transaction A and transaction B. So you save gas, that's one thing. But another point is that you're providing a huge convenience for your users. So rather than having them have to go and approve transaction A and then wait 6 seconds and then approve transaction B, and then wait 6 seconds. Rather than that, we can just say, okay, click one transaction and we're going to do everything for you. So that is a really big benefit to the batch precompile. And one of the examples is, let's say you have a DEX, right? And your DEX prompts users to make a token approval if they want to swap a token. Rather than having them go ahead and approve that token, and then in the next transaction having them actually submit the swap, you can couple the approval and the swap into a single transaction with the batch precompile. And we can combine those two in a manner such that they both have to succeed. So if the approval fails, then we don't want to proceed with the swap. And if we know the swap is going to fail for some reason, then we don't need to even do the approval. So in this case, it only makes sense for the transaction to go through if both succeed. And this is a major deal for security as well, because there are many chains and applications that encourage users to submit unlimited token approvals. This is actually dangerous, and it's not as secure as it could be. If you have the user only make an approval at the time as which they are going to perform a swap, and they only approve the amount that they need for that swap, it's a much more secure operation for the user in the long term. So it's a great practice to couple the approval with the swap. And rather than having them do this on their own and go 1-2 and have it be a little more annoying for them, you can just couple it together, have them do one transaction with the batch precompile. And they won't even, they may not even know that this is, a more secure, better experience, but they're just experiencing it and enjoying it. Okay, so another precompile that we use to improve the user experience is called the call permit precompile. And this allows you to take any transaction and make it gasless. You don't need to make any modifications to your smart contract. This works with any arbitrary smart contract, and this is a big deal. So when gasless transactions really started coming out on Ethereum, they were designed in such a way that you needed to re-architect your smart contract, and typically they worked on a limited set of contract interactions. So the common one that I think most people saw was signatures for token approvals. That's a common standard, but the Moonbeam call permit precompile is not limited to just those token approvals. You can actually do any arbitrary smart contract interaction with the call permit precompile. You don't have to change a single line of smart contract code, and the dApps, meaning you as the dApp developer, you can submit transactions on behalf of users. And the way it works is you're going to prompt your user to sign a message. That is going to give you permission to submit a very particular transaction. So if you have a transaction, say, hey, I want to send 1 Glimmer to so-and-so, that transaction is unique. It has a nonce. It has a global nonce, actually, through the call permit precompile, so that nobody can go and replay or resubmit that transaction at a later date. If you submit it and I said, hey, I really liked receiving that, I'd like to send it again and do it again and send some more. That's not possible because of the nonce and the uniqueness of the transaction. So once you have this signed transaction, you can choose to submit it. And there's also a field within the call permit precompile that's a deadline. And the deadline is a Unix timestamp in seconds. And this is the deadline for the transaction validity. So you might set a deadline of 1 day in the future. It could be a year in the future. But that deadline, if you or somebody tries to, if you have that signature and you try to submit the transaction at a later date after the deadline, it will not go through. But this allows you to design different type of application architectures. For example, you could have a series of signatures, and then perhaps you only submit a particular signature that you need in order to close out a position, for example, or make some sort of on-chain transaction. But you can have this sort of conditional logic where maybe you take a signature, but you don't submit that on chain, right? Maybe you ask the user to re-sign something and then you submit that later. But it allows you to create different type of architectures which can be beneficial to the end user experience and could just be a more efficient way to design an application. And one of the examples here is the Damned Pirate Society, or DPS, on Moonbeam, which has enabled gasless transactions for their users. One of the activities in the game is preparing a ship, and you can either rent a ship or you can buy it yourself. But one of the things that they enable is they allow you to repair the ship using a token rather than using using Moonbeam's native token for gas. So rather than using Glimmer, you can use your doubloons, which is a native token to this DPS game. So you can have utility from these doubloon tokens, and people don't need to go out and get Glimmer for gas. So it's a unique approach and a seamless way for their users to interact with the game. Okay, so I think I actually talked about the batch precompile, but it's useful to kind of go through function by function and show you the parameters that each method of the batch precompile takes. So we have batch sum, which is try to execute all of the calls regardless of if one fails. So if one fails, 2 fail, don't worry about it, keep going, keep trying to execute these subcalls. Now, each function of the batch precompile actually takes the exact 4 same parameters. And those parameters are an array of addresses. So that's the first one that we see here, the address memory 2. that is either the person that we want to send funds to or the contract that we want to interact with. So we'll actually demonstrate. Most typically, you're going to be interacting with a contract address here, but in some cases, you may just be sending funds or tokens. We also need to have, when I say funds or tokens, I mean native token Glimmer. If you're going to interact with a contract, then you would put the contract address of the token. We have a value. You can leave this an empty array. That's totally fine. We also have a call data. You can also leave this empty if you're just sending Glimmer tokens, but more typically you're going to be interacting with a contract and you'll have call data for that contract. So this could be either what method do you want to call, and if it's a method that doesn't take any parameters, then it would just be the method signature, but more than likely it's going to actually have some call data for what data you want to pass to that contract call. There's also a gas limit. This is useful for if you want to section off particular subcalls. So meaning, let's say you only want to give a particular subcall a particular gas limit, and after it runs through that, you just want it to stop. This is optional. You don't need to provide this gas limit parameter. But there are two events which are emitted for each possible method of the batch precompile. One is subcall succeeded, and another one is subcall failed. And then we also have an index for which particular call succeeded or failed. So 0, 1, 2, 3. Something that's important to point out is that each of these parameters are arrays, right? We have an array of addresses, an array of uint256 values, a byte array, and a uint264 array. All of these parameters are arrays. And it's important that for each call, you provide a commensurate number of parameters in your array. So if you have 3 subcalls total, you're going to need to provide an array of 3 addresses. Even if you're interacting with the same contract in each case, you still should be providing that same address 3 times. And this helps you keep everything consistent and make sure that you don't have any unexpected behavior. So even if you're taking the same actions, you still need to repeat the same addresses that you're interacting with or the contract call data. And again, we have batch until failure. This is try to execute every subcall until one fails. If one fails, just stop. Don't attempt to go and execute these later ones. But importantly, don't revert the calls that were already successful. So batch until failure means, let's say we had 3 in total, right? The first transaction succeeds, the second one fails. We don't actually try the third one, but that first call, it worked, so we're going to keep it, and we are not going to, revert that first call. Now, batch all takes the approach that if we have that same array of things, if we have the first subcall succeeds, the second one fails, we don't get to the third one because we already had a failure, and we don't need to try that. We know that the entire call is going to fail, but we do not have the benefit of that first subcall because we said everything needs to succeed or everything needs to fail. Because we stumbled upon a subcall that failed, the entire batch transaction is going to fail. So that first subcall is reverted. It's like it never even happened. Okay, and I spoke about these parameters and the input for each one. So we've got our to array, the addresses that we're sending funds to, or more likely the contract addresses that we are interacting with. We've got our value here. So this is in Glimmer. If you're sending value along with a contract call, or you are sending an actual value of Glimmer, you can include that in the value part. For the third, for the call data, again, this is the call data that for the contract that we're interacting with, the method that we want to call, the parameters, all of that is going to be provided in the call data. And lastly, we have the gas limit, which is, do we want to separate out particular subcalls? Do we want to give them particular gas limits? You don't have to. You can leave it an empty array, open, closed, brackets. That's perfectly fine. And just being conscious of time. Yep. Okay. So we're doing great on time. I'm going to do a demo of the call permit. Oh, sorry, a demo of the batch precompile. But I first just want to cover the call permit precompile. Then we'll get to a demo of batch. So the call permit precompile, I mentioned that it would allow you to make any transaction gasless. So users can sign a transaction in this EIP 712 permit format. And this EIP 712 style permit is a way for users to read the contents of a message that they're signing. So in the early days of Ethereum, when you asked a user to sign a message, it just looked like a long string, like it said 0x, blah, 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 and it was almost impossible for you to tell what was going on, unless you took a very sophisticated and analytical approach at deciphering, this message. So this is risky, right? Because there could be a malicious application which could, try to do something nefarious. They could try to, obscure. Maybe they want to send all your NFTs to their address, or maybe they want to send a bunch of funds to their address and kind of obfuscate what they're really doing. So that was dangerous. But MetaMask and other wallets, they now work with this great format, which allows you to specifically authorize a particular action and then present that to you in a way in which you can see what it's doing. So that includes like showing you the to and the from address, the value, the call data, the gas limit, and all these parameters comprise part of the signature. So I mentioned you have this deadline. You also have the V, R, and S values, which are parts of the signature, which change based on the other parameters that you change as well. So if you change the gas limit or you change the deadline, that's also going to change the signature values of the V, R, and S. So you can't touch the transaction and change it and modify it. You can't do that without also changing the signature. So we actually have a demo app. I can go ahead and open this up to show you. I'm going to connect my MetaMask, and you can choose a particular contract address to interact with. So let's say we want to interact with Moonbeam Incrementer. There we go. I've got this simple contract. It's verified. All it does is have a single method here, which increments by 1. So we want to interact with this smart contract, for example. So let's copy the contract address. Let's head back to the demo. So I'm going to paste that in. I don't need to send any value to it, but I do want to get the signature for the method that I'm interacting with. So I'm going to connect my MetaMask to the page, and I'm going to go to write. And in this case, increment is actually it doesn't take any parameters. So this is the function signature right here, this 0x ending in 08a. We can copy this directly, but sometimes you're going to have parameters, right? And so if you had parameters, you can fill them in, right? You can see there's no parameters here, and you can just copy the raw transaction data, which is this, which matches the function signature right there. So I'm not submitting the transaction, but I'm just getting the data. So we're going to paste that here. The gas limit here for call permit, we actually do need to set a gas limit. So this is different from the batch precompile where I said that we didn't need to have a gas limit. Here we actually do need to provide one. So let's provide 1,000,000. I think that was 1,000,000. Yeah, that's way higher than we need, but we do need to provide a particular gas limit. We also need a Unix timestamp. So let's open that up. This is the current timestamp. If we try to take this, if we just copy it directly, our transaction is going to fail because the deadline will have already passed. So what we can do is we can just move this date to some point in the future. So move it a couple months there. And I'm going to copy that Unix timestamp seconds value. Now I'm going to sign this data here. And you can see I'm presented with this signature request here, which looks, you can see the from and the to, the value, and the data. We also see the gas limit, and we see a global nonce here. So we're going to sign this, and we're going to get back the V, the R, and the S value. These are the components of the signature that we are going to provide to the call permit precompile, which will enable the call permit precompile to dispatch this transaction. So we have a couple minutes left, so I will go ahead and demonstrate this. So just bear with me. I want to make sure I'm respectful of your time. So we have this number, right? 292. That's the current incrementer value. So if we go to call permit on Moonbeam, whenever we have a precompile, right, we always document all of the methods. We document the particular address that the precompile is available at, and they happen to be all the same here across the different networks. But this is the address in which we can access it, and then we can, of course, find the actual interface of the precompile here. So I'm going to copy and paste the contents of the precompile, and I want to go ahead and copy and paste this into Remix. So let's do that. We'll call permit.sol. And this is actually a different MetaMask wallet here, so you know that it's not the same one. So it's actually a different wallet that's going to be dispatching this transaction. So remember I said we always include in the comments here or in a constant, we include the address of the precompile. The call permit one is available at this 0x08A. And we can see all the different values here that we need to provide as part of the call permit precompile. So we have a from address. This is going to be the from address as the user, not the person that's dispatching the transaction, but the from as the person who signed it. So I'm just moving this over here. So we'll paste that in. We'll paste the 2. The value is going to be 0. You got to make sure that all these values line up, because if you put in a different one, even if you're off by just a little bit, then the signature is not going to match, and so the transaction will not be submitted. So this gas limit, don't just don't put in a value that you think is the same. Make sure that you're copying the exact same value. And we've got our V, R, and our S values. Make sure that the order that you have them in is the same, as in you're putting your R in your R value and your S in your S value. So we've got everything prepared, and dispatch is the method that takes all these parameters, it takes the signature, and then it will dispatch the transaction. We can go ahead and press transact, and that will dispatch, if we've done everything correctly, it'll dispatch our transaction. So let's go ahead and try that. Again, we are submitting this from a different account. So 0x3b is different from the account here that I'm submitting from, which was this first one, I believe, the 0x6. Okay, so our transaction was confirmed. Let's head back over to the incrementer contract, and let's refresh it, and let's call the number to see what the value is. If we did everything successful, this should increase, and it did. It increased to 293. So that's exactly what we were looking for. So I'm running out of time, and I don't want to take up too much of your time. The batch precompile is actually, very similar to what we just did in terms of how we interact with the precompile. So what you would do is, if you say, hey, I want to interact with the batch precompile, right? You're going to get this address. You are going to go and get the interface here. You're going to copy this into Remix. And then you're going to provide the different parameters, that it needs. So I can go ahead and just get started quickly and copy it and give you some pointers as well. So we're going to create batch.sol. We're going to make sure that we compile it. One important thing to make sure that you're doing here is after you compile it, make sure that your deploy and run tab here is set to the correct Moonbase Alpha network. So if you're on custom Remix VM here, it's not going to recognize the precompile because it doesn't exist, right? So you got to make sure that you are on the Moonbase Alpha network before you try interacting with a precompile. So we've got batch all. We're going to copy this address here, and we can see the different methods that we can interact with. So I just wanted to demonstrate that when you have multiple parameters here, like multiple 2 addresses, let's say, you're going to have an open bracket, you're going to have a quotation mark, and then an and quotation mark, and then a comma, and then a quotation mark, for example, for open. So just make sure that you are providing these values with the proper formatting here. So this is a common way that folks get tripped up here, is maybe they miss a comma or they miss a set of quotes, and that can cause the transaction here in Remix to fail. If you're not providing a value, right, you can just leave it as an open close brackets. If you don't have a gas limit, open close brackets, that's fine. And then here we're going to put our call data. So in the case of the incrementer contract, for example, right, the data that we're going to provide is this that we had before. And so we can just provide that in the call data field. Make sure you have the quotes and the proper formatting. And then we'll press transact. And then all of that will go through the batch precompile. So I think I mentioned the faucet before, but showing here again, faucet.moonbeam.network. Make sure you use this when you are interacting with the network and to get your Moonbase Alpha tokens.
Thank you so much for listening to the workshop. And I just wanted to mention that you can get help for your project at discord.gg/moonbeam. So be sure to reach out to us on Discord if you have any questions, and we'd be more than happy to help. Thank you.
Hello. Ok, hy vọng thì sau cái clip của Moonbeam thì chắc là mọi người hôm sau là cái video live của phía Moonbeam thì chắc là mọi người cũng học được khá là nhiều từ anh guest speaker. Thì không biết là ở cộng đồng thì mọi người sẽ có câu hỏi nào dành cho guest speaker hay không? Thì có gì mọi người nhắn câu hỏi ra trong kênh chat rồi xong mình sẽ chuyển tới guest speaker để trả lời nha. Nếu như mà mọi người không có ai có câu hỏi gì thì chắc là buổi workshop về Moonbeam của chúng ta hôm nay là cũng kết thúc tại đây. Thì chắc là một lần nữa thì Moonbeam là một trong những cái track khá là quan trọng mà những các bạn mà đang mới vào hệ sinh thái Polkadot thì có thể xem qua về cái track của Moonbeam là Reward Asset Track. Thì cái track này là sẽ expect mọi người xây dựng những cái ứng dụng liên quan tới Reward Asset, những cái mà tokenization, các sản phẩm thật, các sản phẩm vật lý thành những cái tài sản blockchain bằng cách sử dụng Solidity cũng như là những công nghệ của Moonbeam như là Precompile mà mọi người đã xem ở trong clip á. Thì qua đó thì hy vọng là từ những cái workshop này cũng có thể giúp cho mọi người nắm được cái góc nhìn khá là tổng quan về cái track mà mọi người sẽ tham gia. Thì nếu mà bất kỳ mọi người có câu hỏi nào liên quan tới Moonbeam cũng như là liên quan tới track của Moonbeam, liên quan tới chuyện Solidity thì cứ nhắn vào Discord của OpenGuild. Ngoài ra thì ở phía team mentor, team tổ chức thì cũng đã thiết lập cho mọi người những cái kênh để mà cho các team tham gia vào hackathon. Thì nếu như mà mọi người chưa có đăng ký hackathon á, thì nhớ đăng ký hackathon, để mà tham gia, hackathon sắp tới của OpenGuild. Ngoài ra thì mọi người có câu hỏi gì thì cứ gửi vào nhóm riêng của mình hoặc là gửi vào nhóm group chat của kênh Việt Nam. Vậy ha. OK, thì cảm ơn tất cả mọi người vì đã dành thời gian, lắng nghe workshop vừa rồi và hy vọng, chúc mọi người có một buổi tối tốt lành.